Hey guys, I'm just going through a quick video going through our rational zero theorem. This is kind of the last part of our unit before we take our test, probably Thursday, on our solving polynomial. So I just kind of want to go through this briefly with you guys. Those of you that are in person, this is kind of a review for you that you can kind of look back at. Those of you that aren't in person, this is kind of your notes or what we went through today. Okay. So our rational zero theorem is the new theorem that we're dealing with. Essentially, we have our p divided by q. P is essentially the factors of our last term, and then q is the factors of our first term. So that's kind of what we listed here. P over q represents factors of last term divided by the factors of first term. There are quite a few. For a lot of these, there can be up to 20 different factors for this, which can make this a little bit tedious and kind of annoying. But this part is essentially finding every single possible root that we could have. So as we go through this is the steps. It's kind of hard to read. It's a little bit small here, so I'll kind of say them as I go as well. But this is going to give us these 6 steps to kind of solving completely for one of these problems. On our test, there will be 4 questions that are just the regular factoring and solve, and then there will be 2 questions like this where it's going to ask you to solve completely, where they don't give you anything else. Okay? So the way I would go through this problem, the very first thing that we need to know is how many answers are we supposed to get? If we know that, then at the end, I know I'm done when I get that number of answers. So we talked about in class, we talked about before, our highest degree is going to be the number of answers. So this one, the highest degree is 3, so that is also going to be my number of zeros, 3. Okay? Then when I go down to possible roots, the possible roots are once I list each of the factors of my first and last term, it is the last term's factors divided by the first term's factors. Okay? So here if I look at 9, 9 has factors of 1 and 9, 3 and 3. We have to remember that there is both positive and negative values of that. So when I go through and list off my possible roots, we'll always have a positive and negative value of each of those fractions. Here I have a 2 as my leading term, so I have a 1 and a 2 listed up above as well there. Okay? I'm going to move this a little bit closer for this part since we're mainly focusing on this side. Okay, so I have a 1 and a 2, a 1, a 9, a 3, and a 3. So really I only have 3 factors over here because I have 2 3s. All right? We put them, again, factor of last term over top of factor of first term. I'm going to deal with just the ones first. So I have positive or negative 1 over 1. So 1 is on the bottom, this one's on top. My next factor possible will be 3 over 1, again positive or negative. Then 9, positive or negative, over 1. These are all the possible factors with my factor of the first term just being 1. Notice that's 1s all across the bottom. Do I have to put 1 over 1, 3 over 1, 9 over 1? Not necessarily. You could put positive negative 1, positive negative 3, positive negative 9, because each of those divided by 1 doesn't change it. Then my other factors is now putting them over 2. So I'd have positive or negative 1 over 2, positive or negative 3 over 2, positive or negative 9 over 2. And that would complete my list of possible roots. Okay? So these are all the possible roots, not necessarily the actual roots for this problem. Okay? It gives us the idea of where we're going to start. Okay? This is used when I can't factor this the way it is. If I try to do the 2 parentheses of the 4 term, they don't give me the correct answer. So that's when I'm like, well, I've got to do something. So this is that something we're going to do. Okay? So what I would do is I would go through and plug in the week before break we talked about, or we practiced plugging things in. So I would go through and first I would plug in all my whole numbers. So here 1 divided by 1 is 1, 3 divided by 1 is 3, 9 divided by 1 is 9. Okay, I'm going to first plug in those whole numbers just because they're easier. Okay, our goal is to find one of them that equals 0. When I plug these in, I'm plugging them back into my original problem. So this first one would look like this. 2 times 1 to the third minus 11 times 1 to the second plus 12 times 1 plus 9. Okay? When I plug this one in, 1 cubed is 1, so 2 times 1 is just 2. 1 squared is 1, so I have 2 minus 11 is negative 9. Plus 12 is 3. Plus 9 is 12. So this one's answer is 12. What I'm looking for is 0. If I get a 0, then I know that thing's a factor because this last value is my remainder. Okay? So here, if I plug in a 3 into my problem, plus 12 times 3 plus 9, I end up with a 0. So this is one of my factors. I don't have to go through and check every single one. I just need to make sure that at least one of these things work. So I know for sure at the end of this problem, one of my answers is going to be x equals 3. Okay? How does that help me? That gets me to my next step, which is divide by that root. Whatever that root happens to be, we can do synthetic division to solve. So here I have a 3. I don't have to flip the sign because I know that's the actual answer. It's not the parentheses piece. Okay? So 3 is what I had here. They got me 0, so I should have a 3 here. I'll bring down my coefficients. Again, remember, if we're missing an exponent, so if this like x squared was gone, it was just 2x3 and then went to just x, make sure you put a 0 to hold that place. Okay, some of us missed that on our quiz. So here I bring down a 2, bring down my negative 11, bring down my positive 12, and bring down my 9. Synthetic division again, bring this kind of from the past, we're kind of bringing everything together here. I'll bring my 2 down, I don't do anything to that initially. 3 times the 2 gets me 6. We add down, so negative 11 plus 6 gets me negative 5. 3 times negative 5, negative 15, gets me negative 3. 3 times negative 3 is negative 9, which gets me a 0. The last box there, the last little spot, is again your remainder. You should get a 0 there. If you don't get a 0 there, you should be concerned. Okay? So, what this means is my next factor is 2x squared minus 5x minus 3. That is my other parentheses. So technically, this is what I've got going on right now. Okay? You don't have to put this there, but this is essentially what's coming down from that 3. Okay? The next step is to solve. Well, I can solve the first one, x minus 3, pretty easily. We just put equal to 0, and we get x equals 3. This is the one that tends to be a little bit more tricky, so I'm going to put x equals 3 because that's for sure going to be one of my answers coming from this. So I'm going to kind of do this little arrow here. This is the one that I have to deal with, our solving. Okay? Over here it has, for step 5, it says solve. You can factor, use your square root, complete the square, or use your quadratic formula. Normally I will check to see if it factors. If it doesn't factor, then I'm going to quadratic formula. That's my normal kind of routine just because quadratic formula is not too bad with plugging things in. We've done it before. And then factoring is usually the quickest way you can do this. Okay? So to check the factor, I'm going to do a times c, so 2 times negative 3 is negative 6. You list your factors, 1 and negative 6. Those two together get me negative 5, so yes, factoring will work. If you don't find factors that get you that middle term, then you're doing quadratic formula. Okay? So then here I'd have 2x squared plus 1x minus 6x minus 3. We throw our parentheses around it, factor out what we can. So the first term, all I can take out is an x. Second one I can divide out at negative 3. So I would have x minus 3 and 2x plus 1. That is what I get factored from here. I'd put them both equal to 0. X minus 3 equal to 0 is going to get me 3. I don't have to write 2 3's in there, but what I will ask you to write is MULT, multiplicity of 2. Telling me that there's 2 3's there, so I know, yes, you do understand that there are 2 pieces to that. Then I would set my 2x plus 1 equal to 0 as well. When I solve, you get x equals negative 1/2. So my other answer is x equals negative 1/2. That would be my 2 pieces. Okay. Step 6 just says write out your solutions. Okay, so this would be my 2 solutions, or 3 solutions. X equals 3, x equals negative 1/2. At the beginning we said there needs to be 3 solutions. I have a multiplicity of 2 here, so it tells me I have 2 3's and then negative 1/2, which is my 3 different solutions. Okay. Again, there are 2 questions like this on your guys' quiz and tests, and then there will be 4 questions of just the factoring. So again, let me know if you got any questions. We're looking at maybe Wednesday or Thursday for this assessment. All right, let me know if you have any questions. See you guys.